In this section, we discuss the role of the program counter in executing a program and show how the code is fetched from ROM and executed. We'll also discuss the program code in ROM space for various PIC family members. Finally, we'll examine the Harvard architecture for the PIC-18. Another important register in the PIC microcontroller is the program counter, abbreviated PC. The program counter is used by the CPU to point to the address of the next instruction to be executed. As the CPU fetches the opcode from the program ROM, the program counter is incremented automatically to point to the next instruction. The wider the program counter, the more memory locations a CPU can access. That means that a 14-bit program counter can access a maximum of 16K or 2 to the 14th of code from addresses 0000 to 3FFF hex. The PIC family 16F has a 14-bit program counter, while the program counter in the PIC-12F is a 12-bit. In the case of a 16-bit program counter, the code space is 64K or 2 to the 16th, which occupies the 0000 to FFFF hex address range. The 8051 microcontrollers have a 16-bit program counter. The program counter in the PIC-18 family is a 21-bit. This means that the PIC-18 family can access program addresses 000000 to 1FFFF hex, a total of 2 meg of code. However, not all members of the PIC-18 family have the entire 2 meg or 2 to the 21st of on-chip ROM installed. If we look at the table, we can see the 14-bit program counter in the PIC-16 family had imposed the maximum code size of 16K. To overcome this limitation, PIC designers had to introduce the tedious job of page switching to the latter members of the PIC-16 family. They learned their lessons and solved the problem for the PIC-18 family by expanding the program counter to 21-bit for that family. If we look at the figure, 2 meg code space is plenty of space for many years to come. Of course, again, this is a dated text and certainly a dated statement. The data in table 2.6 is from the Microchip website.